The following presentation is part of the Technology and the Corporation Conference Series, sponsored by MIT's Industrial Liaison Program.
My name is Michael Carney, and I work in corporate development for Ambri. Ambri is commercializing the liquid metal battery, which was invented at MIT in the lab of Dr. Don Sadoway over the course of 2006 to 2011. In 2010, Ambri was formed with investment from Bill Gates and Total. We were to take the technology that was the liquid metal battery. The first cell was invented at MIT, and it was a small-scale lab cell. We wanted to take that and make it into large systems for the electricity grid. The technology from its inception has always been about creating a very low-cost energy storage solution, and energy storage is one of the big challenges that face the energy world today. The way electric grids are set up, you have to deliver electricity at the moment that it's demanded every second of the day, every day of the year. And if you're off by just a fraction, then you risk having rolling blackouts and worse, cascading blackouts across regions like we had in the Northeast in 2003. With energy storage, you no longer have to build a system to meet peak demand, the demand that is reached on a hot summer day when everybody gets home and turns on their air conditioning. Instead, you can build your system to meet average demand, charging large banks of batteries with any type of power and dispatching it to meet peak demand, instead of overbuilding your generation capacity to meet that peak demand. Similarly, it helps to integrate more and more higher and higher levels of renewable generation, whether it's wind or solar. They're great resources. There's a lot of opportunity for them, but you can't tell the sun when to shine or the wind when to blow, which makes it very difficult to integrate large amounts of wind and solar into the grid today. Energy storage fundamentally transforms the value proposition for electric utilities and grid operators that need to meet electrical demand at every moment of every day, and that's why we work at Ambri. Ambri was spun out of MIT in 2010 with investment from Bill Gates and Total. They made up our Series A round of funding. In May of 2012, we raised $15 million from Coastal Ventures, Silicon Valley venture firm that has done a lot of clean tech investing. Bill Gates and Total fully participated. So Professor Sadoway was the genius behind the liquid metal battery invention. He has spent many years looking at large electrometallurgical systems like aluminum smelting, and he looked at that system and he said, you know, aluminum smelting is a huge current sink. You have to put a lot of electricity into it, and then in order to create aluminum. Is there a way we can reverse the reaction? Can we put a lot of electricity in and then take that electricity out? And the answer was yes, and that is how the liquid metal battery came to be. Professor Sadoway remains heavily engaged with the company. He sits on the Ambri's board, and he spends about a day a week at our facility in Cambridge helping with different elements of technical development, fundraising, business plan development, and the like. So his presence has been really great for us, and he's quite a he's kind of the pulse of the organization. When he's in, everybody's very excited. So the liquid metal battery is the only battery out there where all three components are liquids. In our case, we have our two electrodes are magnesium and antimony, and in liquid form, separated by a molten salt electrolyte. To discharge the battery, the magnesium will turn into a magnesium ion, releasing an electron to power a light bulb or any other type of load, and the magnesium ion will percolate across the electrolyte, alloying with the antimony in the bottom. In completion, you will have gone from a 3-layered battery to a 2-layered battery with your salt and then a magnesium antimony alloy. The reaction is perfectly reversible when you want to charge. So an electron will come in, the magnesium will decouple from the antimony, percolate back across the electrolyte, and alloy and form the magnesium layer at the top, reconstituting your electrode. This process creates two primary benefits to the liquid metal battery technology versus other battery technologies. First, it allows a very low-cost manufacturing process and design. So you can imagine it's just 3 liquid layers inside of a steel crucible. This is our cell here. It's about 4 inches by 4 inches by 2 inches tall. And to manufacture it, you just have to pour the liquids into the cell. And then you weld the top on, you run a current through it, and you have a battery. There are no separators, no membranes, no pumps. It's all very simple. That allows us to drive the cost way down and be competitive on the electric grid scale. The second benefit is that with each cycle, we reconstitute that magnesium layer. So you have no degradation of that magnesium over time. Now, many folks have iPhones or other smartphones with lithium-ion batteries, and if yours are anything like mine, my phone will last for about 2 days when I first get it, and then after a couple years, I'll have to recharge it every couple hours. That's because of degradation over time of the battery. On the electric grid, that can't happen. You need assets that are going to last for 10 to 20 to 30 years, commensurate with other grid infrastructure, and the liquid metal battery enables that. With each cycle, we reconstitute our magnesium. There's no degradation over time. We have demonstrated in our lab that there is a 0.0002% capacity fade per cycle. That projects out to, after 10,000 cycles, you'll still have 98% of the capacity. Other batteries need to be replaced after 3,000 to 5,000 cycles. We have taken the small cell that was invented at MIT, and now we've scaled it up to large systems at our facility here in Cambridge. We are in the process of assembling our first Ambri core, which will be a 20 kilowatt hour unit, prototype unit that is our first full-scale system in our lab today. We have previously operated a 1.2 kilowatt hour system, stringing a number of battery cells together to get up to voltage that would be applicable for our customers. We have 5 contracts for deployments of Ambri cores in the next year. We're working with First Wind, Hawaiian Electric, Con Edison, the University of Alaska, Fairbanks, and the Joint Base Cape Cod here in the Cape in Massachusetts. Those customers are going to have the first prototype deployments for Ambri, and they'll be cycling it, and testing it, and operating it on conditions at their facilities to get comfortable with the technology and be ready to place orders for megawatts and megawatts of systems when we have the manufacturing capacity available in 2016.